right? From ARD to domain and range. And we talked about that, you know, from ARD, the domain for sine is all real numbers, and there are all these different forms. Okay, so today we're gonna first recap on that. Okay, but first of all, do you guys have any questions? Today's lecture is 2 hours and 5 minutes. So be prepared, okay? I know some of you, or all of us probably would be tired at a certain point. We must, you know, carry on. And, you know, the lecture's recorded. So if you need to watch the lecture, which I think you should watch, every one of you should watch the lecture over and over, because I have put so much, I try to streamline and systematically and consistently to cover these topics. So we can maintain that theme of function and see its various aspects, okay? So without further ado, if you don't have any questions, and if you do, please don't hesitate. Okay, please don't hesitate. All right, domain and range, right? From my investigation, I think most of you guys are pretty familiar with this unit circle, and we have explained why the unit circle, why we eventually come down to the unit circle. Let's recall what is A, right? What is R? And what is D, right? ARD. Does everybody have ARD flashcard in front of you? Yeah? We're gonna dig into ARD. Okay, so I copy and paste our definition, right? So after A, after R, and we got the D. What is a narrative? Yeah, sure, no problem. Okay, if I have to leave for whatever reason, not a problem. Okay, you just have to catch up. You just have to get the lecture after, you know, after you're done with your other things and to watch the recording. That's okay with me. Okay. Thank you for letting me know. All right. All right. So A is an angle measured from standard position. Okay, or sometimes we say it in the shorter notation, A is an angle in standard notation. Okay, so sometimes we make it short. Okay, sometimes if A is an angle in standard position, meaning we measure the angle from either, you know, from either way, either counterclockwise or clockwise. Okay, all from the same place, And a point, you can see it says a point. It didn't say the point, right? So that shows the arbitrary nature of the choice of the point. A point on the terminal side of A, other than the origin, right? We have been talking about these. We have been going back to these sentences over and over. Why? It's necessary. And we also understand it doesn't matter where this point is, as long as it is on the terminal. Okay, as long as it is on terminal. The ratio defined all these different ways, it's going to be the same. Therefore, because it doesn't matter which point we choose on the terminal, therefore we choose the point on the unit circle. You guys with me? For example, as we measure these points, right? We measure these we measure these angles, sorry, we measure these angles. Okay, so I'm gonna measure these angles. The angles are measured from the standard position. The terminal could be here. Then you get a crossing from the unit circle, a crossing with the unit circle. So you have a point over here. On this terminal, the ratio we get from this point is going to be the same as if you choose the point elsewhere. It doesn't matter. As a result, this point is favored because this point on the unit circle gives us some convenience. Okay, do you guys hear the narrative? This point gives us narrative. What is the convenience? The convenience is that the hypotenuse of that right triangle, okay, the hypotenuse of that right triangle is going to be 1, right? You see, the point is here, and this is the point, x comma y. With that point specified, x is equal to, x is a red number, and y is a blue number. Oh, sorry, I meant that to be red. Come on, why don't you change the color for me? Huh? There. You can see that? So that's how the red number and blue number are arranged, the color coordinated. So let's first we make sure we understand this picture very well. A lot of students came to me with a perfect memorization of marking these points, but they actually don't know how to use it. Okay, some of them actually don't know how to use it. Okay, so with that narrative we said from a definition, for example, right? For this point, what does this point mean? This point means you measure angle with a terminal, and this terminal is right here. It happened to be a special angle, pi over 6. Do you guys know the degree of pi over 6? I have not spent much time with you guys about conversion from degree to radians, okay? So if you guys have a question, we can do a special session for it. But now I'm just forcing you guys to get into the radian, okay? So this is a pi over 6. And this terminal, on this terminal, we chose the point, and we choose the point right on the unit circle. And there's this heart right here. Okay, so this angle is pi over 6. This angle is pi over 6. Pi over 6 in degree is 30 degrees. Very good, Elijah. Okay, 30 degrees. Okay, so what is the crossing? The crossing in the definition called x comma y. What is x comma y? And this is x, this red number is x, the blue number is y. And what is it? What is it? The red number, √3/2 is how much? Wait, oh, come on. That's √3/2, okay? And the blue is half. You guys see that? So this number, the red number corresponds to, we do need some AI, huh? Artificial intelligence, so they know what's on my mind. Red, let me use a red arrow. the red number, right? And the blue arrow. Do you guys see that color correspondence? And that is true for all the points on the unit circle. Okay, you guys follow me? That is true for all the points on the unit circle. Therefore, okay, and if you look at all the possible angles you measure, all the possible angles, right? If you look at sine ratio, if we look at the sine ratio, if you look at the ratio for sine, if we look at this ratio for sine, right? The ratio for sine, how is sine defined? It's y over r, right? Y over r. So y over r. But r is equals to 1. Therefore, this is just y, right? Because r equals to 1 on unit circle. So that's a convenience we get. So the input for sine, okay? The input is the angle, and the output is the ratio. And that ratio is, of course, this guy. So that's the output. That's the output. And that output in visual, what is it? It's the blue bars. It's the blue bars, right? The blue bars. Do you guys follow me? So depending on where the terminal, in other words, depending on where your angle terminates, right? You're gonna have a bunch of blue bars to observe. Okay, so let me clean this up. So the output, right? Different angles, different blue bars. Didn't we do this last time? We did this, right? So now it's just a recap, and because soon we're gonna use it. We're gonna use it for a graph. So this is the blue bar. That's for terminal that terminates on this line, crossing this line. I'm gonna make it a little thicker. And that's a blue bar. And that's the blue bar. What's the highest blue bar it can be? 1, right? And what is the lowest? -1, right? -1. There's lots of blue bars in between. Some happen to be special angle, and some of them happen to be not special angle. In fact, between the special numbers, there are lots of non-special numbers. Okay, there are a lot of non-special numbers, but you can just imagine there are lots of blue bars. Okay, those vertical lines. Those vertical lines, they're between -1 and 1. That is the range. That's the value of y. That's the visual. So that's the range for sine. Okay, so we have talked about it last time. So sine of any angle is between -1 and +1, or the absolute value. Where's my absolute value? There. Sine of A. And we also mentioned there are all these 3 forms of the range, domain range, right? -1, especially range. This one, most of you guys know. If you happen to know, you still know. It's the least important. I'm sorry, it's the least used, even though you can use it to get some points. What will get you more points are these 2 forms, in particular, the first one. Okay, easily get you 10 points in calculus classes if you know how to use this one. Okay, so without further ado, we recap on that one. So you can see that, sorry? I'm sorry, what did you say? Somebody said something. Do you have a question? Okay, so that was a recap on sine, right? So we understand the visual, we understand the algebraic. So now the next question is, you can see, in order to process this function, right? In order to process this function, what do we have to do, right? We have to measure an angle. If you don't have a special angle, what do you have to do? You guys did the quiz, right? You guys did the quiz. You have to measure the angle. Happen to be not a special angle. What do you do? And there's a terminal. There's a terminal. And this terminal cross the unit circle, and there's a point. And this one is not that special point. And this point is called x comma y, right? And what is x? This is x, right? This is x. This is how much is red, please. Red, please. Okay. Red, please. Okay, that's the red. Red is x. And what is y? Y is the green. I'm sorry, the blue. And this blue, whatever that value is, okay, is going to be your output. So this is the input. Okay, this is the input, which is the angle measurement, right? And that's the output. Input, output. Sometimes you have clockwise measured angle, counterclockwise measured angle. Your angle may be turned around and around many times. And you end up with a terminal, but that is the input and that is the output. So input is the angle, the output is the ratio. The visual of that ratio is that vertical measurement from the point crossing unit circle to x-axis. Sometimes it could be positive, sometimes it could be negative, right? Last week we talked about the signs of sine and cosine. Do you guys have any questions so far? And next, we want to say, well, how about we establish some direct connections, like the picture we had before, right? From input, you can just get the output directly. You don't have to, do all of these details. Is that possible? In other words, I want to have a picture like this in this rectangular system. Okay, what I'm going to do is that the input is going to be the angle. Okay, input is the angle. The angle, I'm going to use the color of orange. So input is my angle. And the output is going to be that ratio. Change the color. I wish to have some kind of AI, right? So whatever I think in my mind is going to be reflected on the picture. So I don't have to make, juggle these around, right? So this will be the angle and that will be the ratio. So that's the input, okay? So that's the input. Can that be done? Can that be done? This is the angle, right? This is the angle. And this other one is the ratio. Sine of angle. It's that ratio. Can we create a picture like that? How do you put angles on the horizontal measurement? How do you put angles? How do you put degrees on the horizontal measurement? Do you guys see the technical issues involved here? And how did those mathematicians resolve this issue? You know? But you understand the question, don't you? Because angle, degree, or radians is a different measurement. But on the x-axis, right? On the x-axis here, it's a sense of length, how long it is, how long it is. How can you put these together? How do you put these together? So that's what I'm going to explain to you. Okay, that's what I'm going to explain to you, right? So you understand what we want to do. We want to establish direct link, direct connection between input and output. Input, output. So I can just measure the input and then boom, I hit the curve, I get the output, just like we did all the other curves. Remember all the other curves, number 1 through number 21, right? In basic 1 table. Remember we did all of that, right? In one graph, you see the input, you see the output right away. But here you have to juggle, you have to measure angles, find the terminals, identify x, y's, and then identify the ratio. Do you see what I mean? We want to have a more direct link between these two quantities in one picture alone, getting rid of all these other things. So the relationship will be much more straightforward. So this is what's been done. Okay, so I'm going to clean this up. I'm going to explain how to read that sine curve. Everybody know how to draw that sine curve. I have no doubt about it. But do you know what it means? Okay, do you know what it means? I think from my years of teaching experience, a lot of our students didn't know what it means. They didn't know what it means. If you ask them a sine curve, they would just do it. They'll just do it for you. They can do it for you. But if you ask them to mark a point, they can't. They cannot even, some of the students cannot even mark a point on the curve. Say, mark a point for me. They don't know. Then your curve doesn't mean anything to you. Okay, it's just like a worm just wiggles in front of you. It doesn't mean anything to you, right? Because the devil's in the detail. So now let's see what has been done. Okay, the other advantage of having a unit circle is the following. Okay, I'm still using this simple example, pi over 6. Okay, pi over 6. Suppose I use pi over 6. I'm going to measure that pi over 6 from the standard position, and the terminal is going to be the green. Okay, and here's the green. And this angle is pi over 6. This angle is pi over 6. However, do you know what is the length of the arc? Do you hear the word? I said length. Length, L-E-N-G-T-H. Okay, the length of the arc. What is the arc? This is the arc. Okay, so I'm going to mark this arc. Okay, it's going to be a little bit awkward the way I mark it because it's not going to be perfect. This arc length measured from the standard position, also from the standard position on the unit circle, this arc length is of the same value as the angle pi over 6. So this is pi over 6. This angle is pi over 6 in radian. And this arc length is also pi over 6. Do you guys follow me? And of course, there's a formula for it. If you want to know the formula, okay, the arc length is equal to, okay, the angle multiply the radius, and the angle has to be in radian. So the arc length is equal to the angle. If the angle is pi over 6, I kept this secret from my other class, pi over 6. Since the unit is unit circle, so r equals to 1. Therefore, the arc length is what? Pi over 6. Okay, this fact is also used in calculus. So this arc length, the value of this arc length and the angle, which is pi over 6 radian, they happen to be the same value, but in different unit. Do you guys follow me? Same value, but in different unit. And the arc length is a unit for length, measuring length, how long it is, which can be used in our graphing. So we take this arc length, we take this little, little curve, and we make it straight. We stretch it straight, okay? If we stretch it straight, okay, we stretch it straight. We're gonna stretch exactly the same length as pi over 6. Pi over 6. Okay? I don't know what the exact value. If you want to know the exact value, type in your calculator 3.14 divided by 6. It's going to give you approximated value. Do you guys follow me? You can get a numerical value. Pi over 6, what do you get? What do you get? Whatever you get.
0.5235 continue.
0.52 something, right? Thank you. Okay, so that arc length is measured in length. The key word is length. Okay, so this piece is that length, pi over 6. Do you follow me? So this piece is pi over 6. And this arc length is pi over 6. It is right across from the same angle with radian, pi over 6. Do you follow me? Now, what is the sine ratio? The sine ratio is a blue number. The sine ratio is a blue number. So this half, this blue number, what is the blue number here? The blue number in this picture is going to be just this height. And that same height is going to be taken right here, half. So that point will mark, this point will mark pi over 6 comma, the blue number, 1/2.
Professor, is that safe to say the unit for the pi over 6 is radian, pi over 6 radian?
Yes, you can say that, yes. But it's actually the arc length. But we use them interchangeably, but if you say it's a radian, I would say it's not quite concise. It's really the length, the arc length. Do you follow me?
Yes.
They just happen to be the same value. But when you make the picture, you take the length. Do you follow me? But because they're the same value, people use it almost interchangeably. But in fact, there is some minor difference. Okay, but we don't make that distinction because that distinction is almost, omissible. Do you guys see that connection? If you do this for every point, including those angles measured clockwise, you will get that sine curve. Okay, shall we do another one? Shall we do another one? Okay, suppose I'm going to use the angle 2 pi over 3. 2 pi over 3. 2 pi over 3. 2 pi over 3. What's that degree for 2 pi over 3? Two pi over 3. What is the respective degree? You should not need this degree, but just in case to get you guys to understand. What is 2 pi over 3? 2 pi is 360 degrees, right? 360 divided by 3 is 120 degrees. So that's more than 90 degrees. So when you measure that angle, how do you measure that angle? You measure that angle. You terminate here. It's a special angle for sure. Okay, so for now, we're still using special angle. But remember, special angles are in service to ARD. The centerpiece is ARD, not special angles. You guys all understand. These special angles are serving ARD, okay? So some of you guys, when you do a trick 4A, at the beginning with some simple questions you can answer, but as the angles getting more complicated, then you don't. That's because you didn't use ARD. Okay, got it. You're right, Christopher. 120 degrees. So what's the terminal? The terminal, I'm going to use green again. That's a terminal. And we pick the point, okay, at the crossing with unit circle. And what is the sine ratio? What is the sine ratio? The sine ratio is going to be the blue, right? Right? Is the blue, right? Yes? Just like this blue. It was just a little thinner, right? Just like this blue. So this is the blue ratio. You guys see that? What is the arc length? The arc length is going to be measured from the same place, from here. Okay, so measured. Okay, how long is it? I take it out, I make it straight, straighten it out. And what do? I take this arc length and I'm going to measure from the same place. This angle is measured counterclockwise. Therefore, it's a positive angle. Then this is a 2 pi over 3. And you can estimate what's the numerical value of 2 pi over 3. Could you guys give me the numerical value of 2 pi over 3? 2 times 3.14 divided by 3. What is the numerical value? Can someone type that in the chat? I can get it from my software. It's just I have to clean up a bunch of things.
Professor, I got 2.094.
2.094. There, thank you. 2.094. Can you type that on the chat so everybody can see? Where's that sound? Farouz, can you type that number? Oh, 2.094. Okay. So I'm going to measure from the same place, 2.094. So it's about here, right? And what is that blue number? √3/2. √3/2. √3/2. √3/2 approximately, you can get that approximation, okay? I'm just approximating it, okay? So that point will be marked okay, will be marked 2 pi over 3 and root 3 over 4. Wait, I'm into the brown, the orange color, right? The orange color. Does everybody follow me? I'm making all these effort is to want you to see one thing, okay? So this is 2 pi over 3. Okay, and the other one, what's the output? Root 3 over 2. Do you guys see that? 0.433?
No, Professor. I guess I typed in wrong. Root 3 over 4 I typed in. Let me correct it.
Oh, okay. It should be a little bit higher than half. Because root 3 is more than 1, right? But anyway, so that 0.433, whatever it is for something else. Do you guys see the correspondence? This is how you read the picture. This is how you read the picture. 0.866. That's about right. Okay, that's about right. Then you say, how about an angle measured clockwise? Sure, we can do an angle measured clockwise, right? So let's do it. So I'm going to measure an angle clockwise. Okay, still from the same place to measure angles, right? So I'm going to measure this angle clockwise. Okay, let's see what. Okay, I'm going to measure an angle that terminates at a negative pi over 3. Negative pi over 3. So the terminal, I'm going to use a green. Okay, this is the angle. So this angle is negative pi over 3. Negative pi over 3. And the arc length, okay, the arc length is also going to be measured from the same place, clockwise. And this is how much, this is a negative pi over 3, okay, because it's measured clockwise. And negative pi over 3, so this is going to be on the negative side. So I'm going to take this piece of arc length and stretch it straight. And then I'm going to put it where? I'm going to measure negative pi over 3. Negative pi over 3 should be a little bit more than negative 1. So I'm going to measure right over here. You guys see that? So this piece is negative pi over 3. Do you guys follow me? And what's that blue number ratio? That blue bar, what is that blue bar? That blue bar right here. Okay, that point of intersection with unit circle XY is right here. So I'm taking that blue bar, I'm going to copy that blue bar, exactly the same length. Exactly the same length. So how would you mark this point? How do you mark this point? Yes? Are you guys doing this with me? So this is going to be negative pi over 3. The output is that blue number, negative root 3 over 2. Does everybody understand this? Does everybody understand this? Now, let's look at the sine curve. let's look at that sine curve. We will know how to read it. Yes? Does everybody follow me? Are you guys sleeping? Hello? Okay. So now are we ready to see the sine curve? Let's go. Okay. Did you write them down? Right? You see, I have written them color coordinated. Color coordinated. I want you guys to write them down, even though the handwriting is not perfect. Okay. I wish to make them better, but when I write with my mouse, it just cannot be as good as my handwriting. Are we good? All right. So I'm going to clean this up. Did everybody write it down? All right. Clean up. So now I'm going to put my sine curve in there. Sine x. Sine x. So let's do this all over again. Shall we? Let's do this all over again. Now, maybe we'll change some values, right? Now I'm going to measure an angle from the standard position. Am I using A? And this angle terminates. I'm going to use the orange color. Okay, so this angle I measure is going to be here. This is where it terminates. Okay. And what is that angle? What is that angle? Terminates right here. This is your opportunity to practice with angles, right? It looks like it's a 90 degree plus 45 degree, right? 135 degrees. So what is a radian? What is a radian? Pi over 2 plus pi over 4, right? So 3 pi over 4. So that's a 3 pi over 4. Are you guys agree with me? 3 pi over 4. So that angle is 3 pi over 4. Okay, pi over 2 plus pi over 4. Okay, pi over 2 is 90 degrees, pi over 4 is 45 degrees. So add these two, you get 3 pi over 4. Okay, fraction. And this angle is 3 pi over 4. It's arc length. It's arc length measured from here. This arc length. And I take it out, stretch it straight. Okay, what do I get? This is a positive angle, so it's going to be on the positive side. So what is the approximate value of 3 pi over 4? What is the approximate value of 3 pi over 4? You guys get your calculator, give me that number. Farouz, give me 2.356. Is that what it is?
Yes.
Okay, so it's about, thank you. Everybody verify. You guys, this is very important, you guys, okay? 2.356. So I'm going to measure 2.356. It's approximately here, right? And what is that blue bar? Huh? Right here.
1 over root 2.
1 over root 2. So whatever that value is, I'm going to copy this blue bar and put it right there. So this point, you see input, output. Okay, and I'm going to mark these points. I mark this point. The input color coordinated 3 pi over 4 and the blue number 1 over root 2 or root 2 over 2. That's the relationship. That's a relationship. Did you get it? Everybody got it? So now if you draw the sine curve, you can mark some points, right? You can mark some points and know the meanings. It's essential, critical to know this. Okay? I don't know how many of you have been hospitalized. I was hospitalized before. They measure your heartbeat, right? Yeah? Do you have that monitor? They have a sine curve there. Sine curve there. If you know, I was still alive then. I'm still alive now, right? So I will have a heartbeat, just like sine curve, just like sine curve. Now, what happened if it becomes straight? I'm dead, right? Okay, so that's how you read it. Okay, so the blue and this blue, they're exactly the same value. And arc length, okay, arc length. The arc length happen to be the same value as the angle measured in radian. They're in same value, but it has a slightly different meaning. Okay, of course, we almost use them interchangeably, but you need to understand the arc length is a length of how long it is. Okay, when we do this measurement, we do how long it is. Okay, then you say, how about angles go around and round? Well, you just add 2 pi. So your arc length is going to be longer and longer. Got it? So you do the positive, you know the negative. That's how it's been created. So how about for cosine? Cosine is similar. The only difference is cosine uses the red number. Okay, so those red bar, remember cosine is x over r, right? So it's going to be x, right? On the unit circle. So on cosine, I want you guys to create something for cosine. Do you want to give it a try? Have you write it down, all of these things? Does everybody understand?
Yeah.
All right, so let's go to cosine. Okay, so I'm going to clean this up, okay? So how do you like the color coordination? Do you guys like the color coordination? Yeah?
That's helpful.
It's meant to be helpful. Is it helpful? Right, some of you tell me, is it your visual learner? Is this learner, that learner? You have to use we have to use all of our senses to do this, right? But we will try to employ the visual, the audio, all of these different things. You know, when I'm speaking, that's audio. When you visual, but you have to think, you have to put it on paper and write it down and do it over and over again. Thank you for your feedback, okay? So let's look at cosine. Once you understand, cosine is similar. Cosine is similar. So now I'm going to clean up. Let's work at the cosine. Right? Let's work at the cosine. How I'm going to work at the cosine, I'm just going to borrow this picture, right? Over here. And of course, I'm going to remove the curve. Right? Have we talked about the domain and range for cosine? It's pretty much the same concept, right? So for cosine, the definition It's just a slight change. But this change is pretty significant. This change is significant. It's a cosine of that angle. So now it's x over r. But because r equals to 1, therefore, it's equals to x. So this will be cosine of the angle and cosine. And this is x, and that is x, right? So what is x? So once again, go back to the definition. A, R, and D. What's the definition? Definition says you measure an angle, it terminates somewhere, right? It terminates somewhere. The terminal, you pick a point on the terminal, right? You pick a point on the terminal, right? And at the crossing with the unit circle, we're going to use this point, and this point is called x comma y. And what is x? What is y? X is the red. Oops. Come on. Why did you change the color without telling me, right? This is x. And those are the y. The other one is the blue. That's the y. With different angles that terminate at different places, that's how you see the red number, blue number. The red is this red, the blue is this blue. You guys see that? So when we do cosine, the red number is the ratio, the output. The input is still angles. The input is still angles. Does everybody follow me? If you look at all these red numbers, okay? Look at all these red numbers. Those are the ratios. Those are the ratios, right? There's a red number here, that's 1. There's another red number over here, that's root 3 over 2. Do you guys see that? That's 1 over root 2. That's 1/2. And that's a 0. And that's a negative half. That's a negative 1 over root 2. That's a negative root 3 over 2. And that's a negative 1, okay? Cosine pi is negative 1. So some of them are special angles, some of them are not. Imagine there are a lot of red in between red. Do you guys follow me? There are lots of red between red. What can be the red value? What the largest red value it can be? What is the smallest red value it can be? Huh? It's between -1 and 1, right? The smallest is -1, the largest is +1, yes? That's the range of cosine. I think we covered that last time, didn't we? Now, focusing on the red. Okay, focusing on the red. So from the definition tell us, right? Definition tell us that cosine of any angle is between -1 and +1. Right? You can tell from that picture. Or cosine of any angle less than equals to +1. I meant to give you guys a break soon, okay? And the last one, okay, the last one, which is least useful. I'm not saying it's not useful. I say it's the least useful. Is that? You follow me? So from this unit circle, you can tell all the red numbers and numbers between the red numbers. None of them is below -1 and none of them is more than 1. They're always between -1 and 1, no matter where your terminal ends up to be. And that's how the range is between -1 and +1. Okay, so let's finish this piece. So let's finish this piece and then we'll come back, okay? And then I will give you a break. And next, okay, the same way we create the picture, okay? So we want to set up a relationship between the angle and the ratio. We're going to set up a picture straight, just like the picture we did before, right? From the input, you get the curve, you get the output. How about that? That would be straightforward, right? That's what we want. So for example, if I measure an angle right here, okay, it's a pi/3. What's the angle for pi/3? What's the degree for pi/3? Huh? What's the degree for pi/3?
60.
60 degree, excellent. 60 degree. I'm going to cover that, okay. Okay, 60 degree. What is the cosine? What is pi/3? What's the cosine pi/3? It's the red value, which is half, right? Right? Write it down. Example. Cosine pi/3 equals to the red number half, right? You see, input after function, you get the ratio. So now what is that half? The half is this red number over here. Okay, do you guys follow me? Or this one, they're the same thing. They're the same thing. Are you guys with me? These two are the same thing. So what I would do to make the picture, I'm going to measure the arc length from the same place. Okay, measure the arc length from the same place. And then I take the arc length, make it straight. Make it straight, what do I get? Make it straight, pi/3. It's a little bit more than 1, right? This is a pi/3. You guys follow me? So this piece is a pi/3. Positive angle, because it's a measured positive angle. And what is the red number? I'm going to take this red piece, okay, same thing, okay, and copy it. But I make it stand up. So this red bar is the same as this red bar lying down. Because in the rectangular coordinate, horizontal is input, output is vertical. So I just make those red bars standing up. And we do this for every point, for every possible angle, every possible red bar. The same way as we did sine. Did you guys get it? Yes? Are we ready to see the, are we ready to see the cosine curve? Okay, so let's go see the cosine curve. Cosine curve. So let's do it one more time, okay? The arc length, so if we measure pi/3, the color, okay, pi/3. Terminal, am I too slow or what? I hope you guys are not too bored. Are you bored? Because I'm very slow at this place, okay? This is pi over 3. And the arc length is pi over 3. This arc length is pi over 3. And we stretch it straight, pi over 3. Okay, this is pi over 3. So this color coordinated and the red number right here, the red bar, which is the red bar over here. So as a result, this point, when we mark this point, input, output directly, the input is pi over 3. The output is half. Cosine. Are you tired? Shall we take a break? Do you think now you understand sine curve, cosine curve now? Okay. Let's take a break for 5 minutes. Come back at 12:22. Okay, break for 5 minutes. Back at 12:22 p.m. Okay, I'll see you guys soon. All right, welcome back. I did a summary for you guys. I want you guys to check this out. Okay, I want you to recall what we just did, right? The unit circle, right? The making of the graph. Unfortunately, I cannot draw with this software on this here. Okay, so this is you understand this is the arc length to measure the way we specified. And these are the arc lengths we measure the way we want it. And this blue corresponds to the blue numbers here, the blue numbers in the graph here. You guys follow me? This blue bar corresponds to the blue numbers in here. And the red corresponds to the red numbers in the same picture. Okay, do you guys follow me? Domain range. If you study these materials from a trigonometry textbook, okay, I have one over here. When I cover these topics, I actually cover those topics. When I taught a trick, I cover them in different order from the textbook because they have definition in chapter 1. They have reference angle. They have definition, they have an angle measurement and definition in chapter 1. They have reference angle in chapter 3. They have domain and range in chapter 4. Okay, I'm sure the author arranged the material in that way for a certain reason because there's a lot of things in between. But with this kind of arrangement, when you study the topics, you not only have to study chapter by chapter, you have to study horizontally across the chapters in order to get these materials and make that connection. Do you guys follow me? And this is related to how do you study mathematics, such a hard topics, especially for a lay person like me. You just have to do that. You have to do, it's a lot of hard work, lots of hard work, okay? I hope my experience can give you some help, As you do this, as you work these studies, as you go through these procedures, I'm sure you're gonna get your own insight. You're gonna get your insight. But for me, I realize if I trace everything back to definition have told me about all of these things. I don't need to go elsewhere to look. if I want to keep it simple and keep it straightforward, right? So far, we're still working on what? ARD. ARD. Okay? So now every semester I cover these materials in from a slightly different perspective, right? And this semester is no difference. Okay? And next, okay, if you think about what we have done for the first 21 functions in basic one, right? The first 21 functions, I believe 21, okay? No, I'm wrong. The first 14 from number 1 through log x, right? On the first 14 question, what did we do? We did the rule of the function, right? So I'm going to maintain that theme. The function, right? Whatever you call it, f of x, right? We don't call it anything, just the function itself, just the rule, and we specify the rule, and we study the graph, right? We study the graph. We just study the graph, and we identify the domain and range and all of that stuff. So what comes next? What comes next is domain and is x-intercept, y-intercepts, right? Are you guys with me? So next, we're going to study x-intercept, y-intercept. Okay, so I'm going to insert 2 rows. X-intercept, y-intercept. Intercept. Okay, x-intercept, y-intercept. I would like everybody participate, okay, for sine and cosine. From the graph, I'm going to give you 2 perspectives. One perspective is from, you have to understand the rule of function, right? One, you can use a unit circle to figure out your x-intercept, y-intercept. And the other way is use the graph that we just came up with to understand x-intercept, y-intercept. The latter one is actually easier. This one is easier because this relationship is simpler. For example, what is the y-intercept? Let's do y-intercept first. Y-intercept is easier, okay? So let's do y-intercept first. Because with y-intercept, there's only one y-intercept. Why there's only one y-intercept? Why there's only one y-intercept? Why did I declare y-intercept is easier?
Professor?
Yes?
Because there is only one point of origin?
That too. Go back to the definitional function. Christopher, did you want to say something? Why there's only one y-intercept? Chris?
Oh, well, I was going to say it was because there are 2 x-intercepts, but I don't think that's right.
Oh, okay. Well, I want you to hold on to your answer, okay? Don't give it up yet, okay? We're going to come to it. But now I'm asking for y-intercept. Why did I declare there's only one y-intercept for each function? It's in the definitional function. Because what is the special feature of y-intercept? The input must be 0, right? The definitional function says for each input, there's a unique output, right? So for that input 0, there can be only one and only output. If 0 is in the domain, do you guys follow me? So for that reason, if you think about all the functions we have talked about, they all have to comply with that definition of function, no matter what. Okay? For that reason, because y-intercept, its input is 0. okay? And this other y-intercept, its input is what? Is 0. Okay? Every y-intercept has the same commonality. The input must be 0. So if that 0 is in the domain, the output has to be the one and only. It cannot have another number. Do you guys follow me? So this is originated to the definition of function. Do you guys follow me? You don't have to go elsewhere for reason. You just keep applying these concepts and you'll be free and merry. You'll be free and merry. You got it? Now, for y-intercept, x is 0. So when the angle is 0, what happens? The curve crosses the origin. So the x-intercept for sine x is 0, 0. So how about for cosine?
Isn't it 0, 1?
That's it. It's right here. That's where the curve crosses y-axis. That's why it's called y-intercept, right? So when input is 0, output is 1. Do you guys see that? These pictures meant for us to see clearly, easily. Now we're going to apply the concept of input output. Okay, but how about x-intercept? How about x-intercept? X-intercept is where the curve crosses x-axis. Someone just said there are 2. Are there only 2? These curves you see in front of you is not a complete picture of sine. This is not a complete picture of sine. If you look at this piece of picture, yes, there are only 2. But I tell you, there are infinite number of them. That's right, there are infinite number of them. Because if you draw the, well, number one, it's impossible to draw a sine curve completely because the domain is infinite, right? Infinite. From negative infinity to positive infinity, never ending. No machine can do justice to that complete picture. No, none. As advanced as technology is today, no machine can do justice to the complete sine curve. So we have to use our imagination. We have to use our imagination. Therefore, suppose if I give you more of the view, say if I give you more of the view, negative 10 to positive 10, how many crossings are you going to see? 1, 2, 3, 4, 5, 6, 7, right? Now can we start to imagine? There are as many as possible. So how many x-intercepts are there? So what is the concept of x-intercept? What is the concept of x-intercept? So I'm gonna insert another row here. In order to find x-intercept, what are we looking for? Is this function sine function? This is where the crossing of, these are the crossings, right? These are the crossings. What do all these crossings have in common? What do they have in common? Their output are all zeros. Their output are all zeros. So we know the output are zeros. We're looking for all possible inputs. You guys follow me? First, you need to understand this concept. This concept should be very simple to us. Y equals 0. That's right, Vincent. Y equals 0 means what? The output are 0. So to look for y-intercept, you know the input is 0. For x-intercept, you're looking for what? Output is 0. Do you guys follow me? If I know the output is 0, find me all the possible input. That's the question. Do we have that question clear? And how do we find them? How do we find them? Is that question clear to you? Yes, is that question clear to us? Once that question is clear to us, what are we gonna do? You're gonna look for resources to find it, but you have to have the question clear to us, right? So now I'm gonna remove these hearts because I'm gonna move up. On the unit circle, which blue number give us 0? Because the output 0, the blue number is 0. The blue number is the output for sine, right? So now we want the output to be 0. So we're looking for what? So let me enlarge this piece. Do you guys see the connection?
We're looking for multiples of pi.
I know you're figuring out, yeah, absolutely. So what you know that on the unit circle, what will be, so we talk about ARD, right? We talk about ARD. RD. What situation is this? This situation is that we know D, right? Because we know sine. It's about sine function, and we know we know D. We know D, right? Sine of A equals 0. That's what we know, okay? Or you can say if sine of A equals 0. And what are we looking for? We're looking for A. Do you guys see that? ARD from D to A. So what's the bridge? The bridge is reference angle. Right? Some of you already see that. Now, which terminal give you 0 ratio? In other words, what do you see? Which terminal give you the ratio of 0? This terminal and that terminal, because both you have a blue number what? 0. How many angles do we have? Do we have other terminals with this feature, which blue number equals 0? No, no more. So from B, we have identified A, we have identified R, which are the 2 terminal, right? The 2 terminal. How many angles could there be that ends up on these 2 terminals? It could be 0, it could be pi, right? It could be 2 pi, 3 pi, 4 pi, 5 pi, and so on and so forth. Do you guys get it? Did you guys get it? This is a question from D to A. Does everybody see that?
It.
You got it, right? The question is, how do you represent them? The next question, right? Now you understand the visual, you understand the reasoning from D to A, right? So how do we represent it? The representation is the following. Is K times pi, comma 0, okay? And K is the integer. Any integer, 0, positive 1, negative 1, positive 2, negative 2, all included. That's the algebraic representation, K pi. You follow me? K pi. So these are the x-intercepts. How many are there? Infinite. And we can algebraically represent them all like this, right? So if you k equals 0, it's 0, 0. If k equals to 1, pi is 0, right? If k equals 2, 2 pi comma 0, 3 pi comma 0. So reflected on the picture on sine, can you mark those points on sine curve? Can you mark these points? Can we mark these points? So this point is what? 0, 0, right? It's both x-intercept and y-intercept, right? This is 0, 0. And what else? This point is what? Pi comma 0, right? Right? And how about this crossing? 2 pi comma 0, right? Do you follow me? And this point? Negative pi comma 0. Do you follow me? Can you do this? Keep going. Does everybody follow me? Any questions? Do you see how much we have digged out from the definition? It's all in the definition. All those unspoken words waiting us to explore. Because if you choose not to explore, your homework will make you. Period. Your homework will make you. But if you can see that connection, then you will be the master instead of being, driven by these things and don't know what to do. Right? So let's look at a cosine. Let's look at cosine. Are we good? Cosine. Cosine. Okay, for cosine, the issue is the same, right? X-intercept is that we know, the only thing is the rule is different. It's a cosine rule. And it's still, we know the output is 0, right? And we want to identify these points. We want to identify these points. How many are there? A lot. A lot. Many. Infinite. The same thing. It's just as many as possible. But the question is that we know the output is 0. The output in the unit circle, what is it? What is output in the unit circle? The red number is 0, right? You guys follow me? Where do you find the 0 red number? So once again, it's going to be what? ARD, we know the D. Right? So this time is what? Is a cosine A is 0. Where do you find the red number 0? Where do you find them? There's one here, and there's one here. And we found the terminal. We found the terminal. So are there other terminal with a red number equals 0? Not anymore, right? Yes, you look at all the other red numbers, right? They're not 0. So only these two terminals. This is one. Wait, I need to change it to red color. Okay. So only these two terminals, one here and the one here. And you measure your angle always from the same place. Remember A, the definition for A. So you're gonna measure, right? Pi over 2, right? 3 pi over 2. Negative pi over 2. negative 2 pi over 2, 3 pi over 2. And you can keep going, right? So there are infinite number of them. How do we represent them? How do we represent them? Can we still use k pi? What do they have in common? So let's look at what they have in common. Does everybody follow me? So let's look at these angles. Let's look at these numbers, right? Let's see if we can find a pattern, right? We recognize pi over 2. In fact, positive or negative pi over 2 will make cosine equal 0. Positive, negative 3 pi over 2. Right? Do you agree with me? And the list could go on, right? Positive 5 pi over 2. Positive, negative 7 pi over 2. You can keep this list going on, but you probably will get some point when the similar question is asked. The question is your nerdy professors expect a little bit better. Especially your, professors at 4-year school. Oh, they're demanding. They're very demanding. They want more. They want to have a nice, sleek representation of all of them. What can you do? Yeah, you want to get points from them, don't you? What do? What pattern have we recognized? In this case, we start to recognize patterns. This is very important. It's even important for your calculus too, okay? Chapter 12, chapter 11, I think chapter 11. Right, Farouz? So yes. 1 times pi over 2. Is that right? 3 times pi over 2. And this is 5 times pi over 2. And this is 7 times pi over 2. So what pattern have we recognized? Odd number multiples of pi over 2. Do you agree with me? Can you say the words? Do you agree with me? I could be wrong. Okay, don't have that. Don't have that myth of that I'm always right. I'm not. That's a terrible burden for me. But this time, maybe I'm right. Okay, be critical of my statement. Always. Even I'm critical of my own statement. So what do we have observed? The odd number, right? Right, this is 3, sorry, this is 3. 1, 3, 5, 7. Do you guys see that? So it's an odd number multiples of pi over 2. Do you agree? So when cosine assume those values, the output will be 0. But how do you express odd number? How do you express odd number? Did we talk about this before? 2k plus 1 pi over 2.
You also mentioned 2k minus 1, Professor.
That's right. 2k minus 1 works too. Okay, so you can use either one. Most of people, they like 2k plus 1. Okay, some of those professors, they like 2k minus 1. But these are the things you see in the literature. And guess what? You are a professor in 4-year schools, including your professor teaching calculus classes, they expect these things from you. Okay? All right. So these are the quantities will cause what? Will cause the output equals 0. Therefore, the x-intercept will be 2k plus 1 multiply pi over 2. Odd number multiples of pi over 2. I think the words should help us to understand. Okay, the words should help us to understand. Okay, comma, 0. So I'm going to put a point right like that. Okay, where k is integer. K is integer. Did you guys get that on the table? Any questions? And next, we're going to move on to tangent, cotangent, secant, cosecant domain. And possibly range. Okay. All right. Are you ready? We're still exploring the definition, ARD. We're still exploring the definition. You can see how much has been told from the domain. From ARD, how much has been told. Right? So let's look at tangent and cotangent. Are you ready? Tangent and cotangent is going to take us a little bit more time, especially tangent. Cotangent is not as much used. Therefore, we're going to study tangent more in details and will not study cotangent that much. Okay, but we will mention the domain of cotangent. Secant, cosecant are not used terribly much more. Therefore, but we still mention their domain and range. Okay, I want you guys to see the connection. I want you guys to see the connection. Okay. Did you guys write it down? Did everybody write it down? So far, so good? Yeah? So let's look at tangent and cotangent, right? Let's look at tangent and cotangent. Now, for tangent. For tangent, I will have to recall the definition, right? I think we have a better summary over there, right? We have a better summary over there. So I'm just going to look at tangent and cotangent. The definition tells us some other stuff. For example, for tangent, right? We're back to the definition. We're back to definition. So back to definition. So today we finished from ARD to domain range for sine. For sine, cosine, right? And we did the graph. So let's look at tangent. Let's look at tangent. Okay, tangent. Tangent A. Oh, so ugly. Tangent A. And we go back to the definition. We're going back to the definition. Okay, we're going back to the definition. And I want to simplify all of that stuff. Okay. Okay. From definition, how is tangent related to sine, cosine? There are many approaches to this, but I feel I recently used this approach. I think this approach will make it easier for you, right? Everybody knows this fact, right? Tangent A is sine of A over cosine of A, right? Yes? Yeah? Does everybody agree? Because you see why? Right, from definition, tangent is sine A over cosine A, right? Does everybody agree with that? Do you want me to derive that for you?
Yeah, I agree.
You agree, okay. You agree with that? So what is the domain for tangent? Cosine A has to be 0. Domain is cosine cannot be 0, right? The denominator cannot be 0, right? Yes? What will make a cosine equal 0? We just did that table, didn't we? What will make cosine equal 0? When these angles are used as input, cosine will be 0, right? You follow me? You guys see that? Therefore, what do? This is the number right? To guarantee tangent is meaningful, denominator cannot be 0. What will guarantee cosine will not be 0? The angle cannot equal to odd number multiples of pi over 2. Does that make sense to you? Does that make sense to you? That's the domain for tangent. How about cotangent? How about cotangent? Cotangent is x over y, right? Which is the cosine over sine, right? What would be the domain for cotangent? What would be the domain for cotangent? Well, sine A cannot be 0, right? Because it's in the denominator, right? And what makes sine A equal 0? We go back to the table. What make cosine? What make sine A equal 0? K pi. Are you guys with me? You see how naturally they're connected? So A cannot be what? A cannot be what? K pi. And of course, K is any integer. How about secant and cosecant? How about secant and cosecant? What about secant and cosecant? From definition, cosecant, secant, we all know there's that relationship, right? Cosecant is 1 over sine, right? Yes? You guys see that? Yeah?
Yes.
I bet you know that. And sine is in the denominator, therefore all of these can be what? Can be repeated just for cosecant. Right? How about for secant? How about for secant? Secant is 1 over cosine, right? Right? So cosine cannot be 0. Cosine A cannot be 0. And what would that be? You just copy and paste the entire thing here. So from sine and cosine, you figure out domain for all of the rest of the functions. Does that make sense? And it's all in the definition. You just have to figure out. If you don't figure out, and you'll be given questions about it. Does everybody follow me? So let's summarize these domains, okay? Let's summarize these domains, just on domains. Summary. Okay, you can see that logical connection. Logical connection, I'm talking about logical connection, okay? From the definition. Okay, I would still say from ARD because definition is dependent on ARD, right? On A and R, right? So when we summarize this, so I want you guys to do this with me. 3 columns, maybe 4 columns, number of rows. Okay, so this is just about from ARD to domain. Okay, picture is the other thing. Okay, so domain is one big issue. Okay, we know sine A, cosine A, tangent A, right? Sine domain is all real numbers. That's no question, right? We never encounter, dividing by 0 because the R, the radius will never be 0. Tangent, however, because tangent is equals to sine over cosine, whatever make cosine equal 0 cannot be in the domain. Therefore, what else? The domain for tangent is going to be this guy. Right? How about cotangent? How about cotangent? Cotangent, I'm going to put it next. I'm going to put it here. Okay, we'll make adjustment as we need. Okay, cotangent A is equals to cosine A over sine A, right? So whatever makes sine A equals 0, that cannot be. So cotangent's domain is going to be what? It's going to be like this. A cannot be any one of that. And K is integer. Do you guys see that logical connections? After you make this table, I assure you, you don't have to memorize anything. After you go through this process, you made this table, you don't have to memorize it at all.
Professor?
Sorry?
Professor, is it important to mention the tangent and cotangent, the domain also, negative infinity, comma infinity, then exceptions, are the A cannot be those? Domain for tangent and cotangent.
What did you say about the tangent and cotangent? Are you talking about domain?
Do we need to mention also negative infinity?
You're talking about range. You're talking about range.
No, domain. Domain for the tangent, cotangent, shouldn't we just also mention negative infinity to infinity like we have mentioned it for sine and cosine? Then
no, exception. The domain is not from negative infinity to positive infinity.
It is the angle, right? The domain input is the angle A.
Right.
A could be from negative infinity to positive infinity angle.
No, the angle cannot be these. Okay, the domain for tangent can be any real number but these.
That's right.
Okay, that's what you say. But
yes.
This notation means any real number except
A, not except equal to
that.
That's correct. That's correct.
That would be the narrative,
yes.
Okay? And
yes.
for this other one will be any real number except. So this notation means any real number except.
That's right.
All right? Yeah. Any real number except. So that's how you read it. That's how you read it. So now let's look at secant, cosecant, right? How about secant, cosecant? Secant is 1 over cosine, right? So secant is 1 over cosine, right? And they have the same denominator, don't they? So they are going to share the same domain. Cosecant is 1 over sine A. So they're going to share the same domain. Does everybody follow me? You must understand the logical relationship, which is the key. Otherwise, all these table summaries is no use to you. Do you follow me? Yes? You see, we summarize after we went through the reasoning. Riley, are you about to say something?
I was just about to say that makes sense to me.
Thank you.
I have a better understanding of sine and cosine than I ever did.
I'm sorry?
I have a better understanding of sine and cosine than I ever did.
Thank you. Good. Any other questions you have, please? You can see how they're related, right? How they're connected by definition.
Yes,
right?
I see it.
They're all connected. It's all in there. You see, it's all in here. It's all in here. It's all in here. Nowhere else. Okay, so domain is about the input, and we haven't talked about the range yet, because the range for tangent, cotangent, secant, cosecant, there will be more tricky. There will be more tricky. Okay, we're not going to do all 6 functions, everything, because we don't have that kind of time. But we will do some of the important functions, such as tangent, and cotangent. Okay, so next we're gonna work on the range. We're gonna work on the range and the pictures, the range and the pictures. Okay, so what does definition tell us about the range and pictures of tangent? Okay, we still have some time, so let's go for it. Let's study tangent, right? Let's study tangent. For tangent, we have unfinished business, right? Because for sine, cosine, we have finished what? Excuse me, we've done the graph, right? For sine, cosine, we've done the graph. We did domain and range. We have done domain for tangent, right? We haven't done the range for tangent, and we haven't done intercepts, right? So we have more to do. So in the end, we're gonna have all of them, completed. All right. Now, let's look at tangent. From that unit circle, how do you find your tangent value? For that unit circle, how do we find our tangent value? So I'm going to remove this picture, remove this guy, right? Because we're going to graph the tangent. Sorry. I'm going to remove this picture. We're going to graph tangent. So it's empty. It's an empty sheet. It's an empty sheet. We know the domain. We know the domain. What's the implication of the domain? It can be all real numbers. All real numbers, but. Okay, this is a typical mathematical description of a domain. When they write it like this, it's a shorthand notation. What it says is any real number but these. Do you guys follow me? It's a shorthand notation, any number but the odd number multiples of pi over 2. Okay, so now the question is, when we plot this, we certainly can avoid this, right? What are the points that we cannot take? What are the points it has to be out? Anything make a cosine equals 0, right? So what make cosine equals 0? The red number equals 0. So this terminal is out. This terminal is out. And that terminal is out, right? These terminals are out. That's what it means, right? We did that earlier. Figure out the domain, right? That these two terminals are out. But you can have a lot of other terminals, right? You can measure angles. Whoops, sorry. Yeah, that terminal is out. But you can have other terminals. You certainly can. You can have this terminal. You can have this terminal. However you measure the angles, you can have all these other terminals. That's okay. You can also have terminals that very, very, very close to the forbidden one. Do you follow me? You can have terminals that are very, very, very close to the forbidden intervals. And we wonder how would the tangent value behave in those places, with those angles, don't we? Because in mathematics, we tend to study the ordinary case, and we also want to study the extreme cases. Are you with me? We also want to study the extreme cases. All right, so now let's get started. Right, so we are going to study those extreme cases. Are you ready? Okay, graphing wise, suppose I want to graph the tangent, right? I know it's a ratio, and I still want to have this piece is, the horizontal is angle, right? The horizontal is angles, right? The output is on the vertical. The output will be the ratio. And in particular is tangent ratio, right? So we want to have still the arc length, okay? The horizontal is still the arc length of that angle on unit circle. And the ratio now this time is going to be the tangent ratio, which is sine over cosine. Sine over cosine. Sine is a blue number, cosine is a red number. So it's a blue number divided by the red number, isn't it? You guys follow me? Yes? All right, so let's do a few numbers. Are you ready? I know you must be tired. Okay. Oh, we have 7 minutes. Let's do a few numbers to get you started. Now, we cannot take any angle with a terminal, which is a forbidden terminal, but we can take these other terminals, right? All the other terminal will be okay. So I start with 0. So what will be tangent 0? Remember, tangent is a rule. Okay, we always go back to that rule. And that rule says tangent of A, it gives us a ratio. That ratio is what? Is y over x is the blue number for those special angles or non-special angles to red. Right? So in this particular case, when A is 0, what is that number that corresponds to A equals 0? A is 0, input is 0, so tangent 0. Tangent 0 will be the point On the terminal, I'm citing the definition, the point on the terminal, and I pick the one on unit circle, I get 1, 0. What would that be? The y is 0, the blue number is 0, the red number is 1. 0 divided by 1, what does that equal to? 0. Oops. So tangent 0 is 0. So now we get a dot. We get a dot. 0 input, angle input, the ratio is 0. I'm going to put a red dot over there. Okay, so this point is 0, 0. Now, how about pi over 6? There's not much of measurement need to be done. How about pi over 6? So now pi over 6 is the input. Serve as the input, go through the tangent machine. And what do we get? Tangent pi over 6. Right? If you know, whether you know or not, I want you guys to put on your thinking cap, get a paper pencil to enhance your algebraic skill here. What is the terminal? The terminal is right here. Okay, the terminal is right here. Crossing with the unit circle, we have a point, √3/2, 1/2. The blue number is sine, the red number is a cosine. So I'm going to take these two numbers and put them in place. Yes? So this is going to be the blue number divided by the red number. Can you simplify that? Can you simplify that?
Oh, would it be square root 3/3?
That's right. Okay. So we multiply 2 and 2 on both top and bottom. 2/2. So the top will be left with 1. The bottom will be left with √3. And rationalize it. Some of you probably know this number. Rationalize it. Some of you know the √3/3. But please do this work. Make sure that this, because remember this class is 5 classes in 1. We're learning across the courses. Okay, so this is equals to √3/2. You are absolutely right. Does everybody follow me? Okay, so tangent pi over 6 is √3/2. Pi over 6 the input, √3/3 is an output. So now I'm going to measure that point. What I'm going to do, I'm going to take that arc length measured from here. That arc length. You guys follow me? I'm sorry, this is an ugly piece of arc length. Yes, but you forgive me, right? Do you? The arc length. Let me do it one more time. The arc length, pi over 6, I'm going to stretch it straight. Okay. Approximately here. That's the input. And these two orange colors of the same length. Okay. And then what? This time is neither blue nor red. It's a ratio of the red over blue. It's a ratio of blue over red. Okay, red divided into the blue. We got √3/2. So √3/2, whatever that value is, I'm going to use purple. How about that? Right? That purple color. And that point is, okay, we're going to conclude today's lecture. Okay, this is the pi over 6. Let me do the color tone. The orange color. So that's the pi over 6, comma, the purple, okay, root 3 over 3. That's just one point. No, this is the second point on the tangent curve. You guys follow me? And of course, this is the beginning, but do you see the consistency, how we produce these curves from sine, cosine to tangent? The input are angles, right? And in particular, it's the arc length of that piece measuring the angle. All right, that's all for today. See you guys tomorrow. I'm looking forward to it. Great job, great participation. It's a very long class.
Thank you, Professor.
Thank
See
you,
you
Professor.
tomorrow.
Good job.
Thanks for the lecture, Professor.
Of course, it's always my great pleasure. Thank you guys. I'll see you guys tomorrow. There's homework, okay? There's homework.